Hello, my name is David. I'm presenting for Project Team 10. Our topic is MySQL Performance Schema versus PostgreSQL Statistics Collector. So a little background here. So one of the most important or unimportant criteria for determining which DBMS offers the best performance is which analytic tools are bundled with it. The earliest DBMSs were proprietary software and only included a minimal set of monitoring tools that were provided by that company because they had to program it and all the features. It was a very restrictive setup because it limited what you could do with it, and sometimes it didn't even run on all operating systems, so only certain people were able to use it. This helped to open up the open source movement and started to gain momentum because more and more people wanted to have some sort of solution that was open and easier to use. So this led to many improvements on how we store and analyze data today, and also flooded with the amount of different options we have now to use for databases than we did before. Open source DBMSs and platforms allowed more developers to be able to contribute to those platforms by adding tools and other third-party software that added more functionality and features over time. All of this helped to increase the number of analytics tools and third-party software that were available, which helped a lot in improving the performance and usability of DBMSs overall. So then the next question became, how do we measure this performance? Like how do we make DBMSs and databases work more efficiently in terms of performance and I/O access? How do we improve query speeds? And also, how do we take measurements of this performance and analyze it to study how we can improve it? So the problem we're looking at here is which DBMS offers the best suite of performance analytics tools that help us to monitor and tweak performance of our database. So the goals and the objective of this project was to compare MySQL database performance schema and PostgreSQL statistics collector tools, and then we wanted to look at their feature sets, their interface, and also look at the performance metrics that they offer. Then we want to try to find a large data set, a database, so that we could perform queries and gradually make the queries more difficult and see how the performance changes with the increase in complexity, and then compare the performance of the two tools to each other. Our approach, we decided to use the Australia weather dataset and create a database on both platforms. So one on MySQL, one on Postgres. And then we came up with 5 queries that we were going to run on both databases. And then using the performance schema for MySQL to measure performance of those queries on MySQL, and using statistics collector for Postgres to measure performance on that database. And then compare the two UIs and features of both analysis tools, and also compile the results and determine which one's the best tool. So a little bit about Weather Australia dataset. It's a collection of data from the Australian Bureau of Meteorology, and it's sourced from over 50 different weather stations across Australia. And they started compiling this dataset back in 2008. So now the dataset consists of 142,000 plus rows, and it's looking at 24 different attributes. So there's 24 columns of data. Okay, so now we look at the queries that we ran. We started out simple, and then we gradually increased the complexity of the query so that we can see the difference in how it handles the different tasks. So first one, we're just looking at all the locations that had rainfall greater than 100 millimeters, and then we just sorted it by the rainfall amount. Our second query, we're then comparing which places had a minimum and maximum temperature that was equal, and then also a min temperature greater than 0, and then we sorted it by that minimum temperature. Our third query, we're now grabbing 6 different columns of data and to display, and we're looking at all the ones that have predicted for rain today and rain tomorrow, and that have a risk of rainfall of 5 millimeters or greater, as well as rainfall greater than 1. And then we're going to sort it in descending order based on rainfall for that one. The fourth one, we're looking at 4 different attributes, and we're looking for all the locations and all the rows that have a risk of 50 millimeters or more of rainfall. And we also want to make sure that all the rainfall column, we're only looking at rows that have data on them, so not null. And then we order those by rainfall. And the last query we looked at was also 6 different attributes. And we're looking for location that equals Adelaide. So we only want to look at Adelaide's data, and then only the rows that have a risk of rain, basically. So risk millimeter greater than 0 and rainfall greater than 0. And then we're actually organizing this by date instead of by the rainfall.
My name is Hadi, and I will be continuing on the presentation from this point forward. So after running those 5 queries, we got some results, and we placed a summary of them on this slide. For queries 1, 2, and 5, we notice that the execution time for Postgres is less than the execution time of MySQL, but the fetching time is greater than the fetching time of Postgres is greater than the fetching time of MySQL, with the exception of queries 3 and 4, where the fetching is actually significantly less than the Postgres compared to MySQL. Now, on top of that, Postgres, the execution time, it's either half or less than half the execution time of MySQL for all of the queries. Now, as you can see here, we've displayed the graph. The graph on the left shows you the execution time for Postgres versus MySQL for each query, and on the right, it shows you the MySQL's fetching time versus Postgres fetching time. As you notice on the left, what I told you in the previous slide, Postgres execution time is either half or less than half the execution time of MySQL. And here you'll see what I tried to present in the table previously, that Postgres fetching time is all over the place. In some queries, like 3 and 4, it is significantly less compared to MySQL fetching time, while in queries 5, 2, and 1, it is larger, and sometimes multiple times larger, or in this case, multiple times longer. However, when we take the total time as the execution time is the fetching, as the total time is the fetching plus the execution time. So when you run a query, it's the fetching time plus the execution time. That's how long a query takes. In all of the cases, Postgres is half or slightly less than half of the time that MySQL takes. And this is using the Postgres statistics collector for Postgres and MySQL performance schema for MySQL. So we notice here that Postgres actually performs significantly faster and is more efficient and optimal than MySQL. Now the next thing is we need to compare the user interface, because if one person is going to use one tool over the other, we need to know how they're going to interface with it. The problem in this case, both of them are both command line and just command line interfaces. So now we're stuck where you have to be proficient in command line in order for you to use these tools. Now, we're going to compare the features of both of them, as there are features that Postgres Statistics Collector provides due to PostgreSQL that is not provided MySQL performance schema because MySQL doesn't provide it. So table indexing and replication cannot be done in MySQL. So performance schema cannot take advantage of that. While Postgres is Statistics Collector, it's allowed in PostgreSQL, so then we can do in PostgreSQL. In-memory database creation is supported in MySQL, but it isn't in PostgreSQL. There is no overhead analysis. There's no overhead on analysis when you're doing on MySQL, but there is on PostgreSQL. Defragmentation methods, there are significantly more in Postgres than there are in MySQL. There are more. MySQL performance schema can take advantage of the defragmentation methods that are in MySQL that are not in Postgres. Mutexing is not possible in MySQL, but it can be performed in PostgreSQL. Temporary tables, it's limited in MySQL while it's much more advanced in PostgreSQL. As you see, both tools provide you ways to collect information on a database, so you can see its usage and its statistics over time. The interface is very similar and it's accessed the same way through the command line. And both are in active development. So we can expect in the future, just like what happened to MySQL and PostgreSQL, more features to come in. And here's a summary of where the features that PostgreSQL Statistics Collector takes advantage of, which is the table indexing and replication, mutex, and better compatibility for temporary tables. While MySQL Performance Schema supports in-memory database creation, no overhead analysis when you're using the tools, and better capabilities for defragmentation methods. Now, when we take everything together, performance, the interface, and the features, Postgres MySQL Statistics Collector is the tool that people should be heading towards to use, as Postgres is really efficient. The features in it that Postgres Statistics Collector can use are better than MySQL. Now, we did face some challenges, and the most important one is the operating system, as the database management system runs on the operating system. Even though Linux is beginning to emerge, and now Linux has become a de facto alternative to Windows and macOS, the problem is the kernel is becoming less and less open. So now we're becoming to know less and less of how the operating system runs, and that brings a problem because now we added another factor, and now we don't know how the operating system is running. The other problem is the analytic tools themselves. You can only use MySQL statistics, MySQL performance schema on MySQL, and the PostgreSQL statistics collector can only be used on PostgreSQL. So now we've got different tools that are going to be measuring the data differently. This is a problem because this cannot be in one-to-one comparison. We did notice that PostgreSQL was faster than MySQL, but is it exactly as the way we described it, at half the time? That's a problem that can only be solved through solutions, which we will discuss in the next slide. So the next steps that we should take is that we need an alternative operating system, one other than Linux, that is open, minimal, and doesn't have a significant overhead, so that the database's management system's performance is not affected. A tool also needs to be developed so that we can analyze all of these databases consistently in a way so that when we compare numbers, we know that this database management system is either worse or better than this other database management system. I hope you enjoyed our presentation and have a great day.